So I did some more measuring on this pilot bearing. That's still 5.1 and then or 0.51 rather. It didn't change, but the transmission bore now without the pressure plate on there, I can see it is it's designed for the full depth of the pilot bearing. So that is 520. It actually was like 505 doing it without or with two hands. So I stand corrected on that whenever I was looking at my measurements here. I was saying that it was, I don't know, can't remember how many inches. Looks like a couple eighths. I think I'm still gonna just seat this thing to here and give me an extra little bit on the input shaft, just so it's not riding right on the edge of that. And if that gives problems, well, you guys will be the second ones to know. I'm gonna stick this bad boy in there, and then I'm gonna try to slide the tranny in it today. We'll see. I'm gonna do the old grease trick on the end of this thing and see how far in it sits. Boy, that's snug. Wow. Like snug. Like almost a press fit. Wow. Okay. Good to know. That might fight me a lot in and out. Yeesh. Both directions. That thing's, well, you see it's got wear on it, so it's got to be under what it's supposed to be. Well, it's 590 right on the nose, which is what it's supposed to be. What's this guy? A little bit over. Well, if you trust the science, it says it should go. So, we're gonna roll with it. If I gotta beat it in, I guess I gotta beat it in, you know? We'll put the input shaft in the freezer. Alright, I'll pick back up with you when I'm ready to put the tranny in. I'll have the... Right now it's sitting in pieces. I just cleaned up the bell housing so it didn't get all greasy again. So, I'll press the bearing in, put the oversized pressure plate. Why am I struggling so bad? The oversized clutch in it, so it'll just slip right through there. And then see if we can get the input shaft into the bearing. Alright, I'll be back in a little bit. So here's what we got going on. I put her in right about to that groove. I did my best to measure it. I think it's pretty well straight all the way around. I think it's hard to get them crooked, but it started kind of crooked, so I don't know. I was trying to do something with feeler gauges. It didn't go very well. But it's got a little snap the whole way around it, so I think it's about the same height. I tried to measure it with a set of calipers. That didn't work either. So, you know, we'll roll with it, and if it's crooked, well, I guess it'll wear itself out, and then I'll just pull it apart and do it again. So, that's what we got. After I stick that in and see how deep it goes, then I guess I'll see if I have to put it in more or not. So, more to come. So, like most things, the first test fit went poorly. And here we are back on the workbench. This is kind of unforeseen, but now that I'm seeing it, I see it. This sticks out quite a bit further than the flush one. I think that's just for more engagement. I don't know what that's for, because this side doesn't stick out. The flywheel side doesn't stick out at all, but the pressure plate side sticks out a lot. On the 6.5 clutch, the pressure plate side is flush. The flywheel side has the stick out. This isn't a problem. The 6.5 clutch fits in the hole with tons of clearance between that and the flywheel bolts. The problem lies in my input shaft, homemade one. Input shaft. Release bearing. Oh, it's underneath the clutch. This doesn't clear. That sleeve runs into that. By the time I tighten the bell housing down onto the block, it's just not enough room. So then I started looking to see what I could make work. I said, well, why are these different? So I laid them this way. And when you lay them this way, the transmission face of those is without an angle iron in the way. They're about an 1/8 inch off, maybe a little more. So, like, well, I can't take an 1/8 inch out of this thing. It's about as close as I can make it without a lathe. I'm trying to do this without any machining equipment because I don't have machining equipment, and most people trying to do this don't have machining equipment. And it'd be pretty cool to, you know, do it all with what you got and a little bit of talent that I clearly don't have. So I was like, well, I'm not using this friction disc anyhow because it's a 1 3/8 inch spline shaft. I was like, well, let me run the 6.5 clutch then and see what it does. So, oh yeah, there's also, because everything was going so great, out of desperation, I grabbed what's left of the clutch of the 4.3, and just for seeing the hub diameter of the two. So if I have to, a small block Chevy clutch seems like it'll work. Let me show you why the 6.5 doesn't work. When you put it up against the flywheel and then you go to put the pressure plate on, the clutch doesn't fit inside the freaking pressure plate. It is just barely too large of a hub. This is a South Bend friction disc. It looks a lot like the Sachs on Rock Auto. Rock Auto has another friction disc. Let me pull that up on the computer quick. So here's what Rock Auto has to offer. Unfortunately, the what do you call it? Auto parts. I can't buy just a friction disc, but you can at Rock Auto. So let me open these two up and back. Heavy duty. So these are both 1 1/8 input shafts. Well, these are loading. I'm going to set up the camera stand so that you can see a little better. And by camera stand, I mean, once again, cell phone on the bench vise. So this is the Sachs clutch, the heavy duty one. Sorry, impact. And it's a little bit different design. They don't show you the face that doesn't fit. They just show you the what appears to be the flywheel side of things. This side. So, I don't know. This one's got 6 big springs and 4 little springs. And the impact has, what, 2, 4, 6, 8 little springs. Maybe this hub is machined slightly different to where it, I guess stamped would be the better word, to where this is small enough to fit inside the pressure plate. This one here is the Sachs. It's pretty much identical to the one I have from South Bend. I don't think I can zoom in on this thing any better, but if I do that, you can kind of see the 6 big springs, the 4 little ones in the center. It's got the Teflon ring there, kind of like what this one has. You got this ring, then 4 rivets in the middle, and then the 4 big springs. So, near as I can tell, South Bend uses a Sachs clutch, at least for the 6.5s. This is kind of difficult because now I have to decide whether I'm going to use an 1.25 inch or a 1 1/8 input shaft. I was hoping it was all going to bolt together first, but I mean, my other option is if I went back to here and grab myself a Dodge. So here's the Dodge impact. It's a 12-inch disc. Let me see if I can move you around some more. How's that? So that's a pretty similar build to the 6.5 clutch. Just different size splines. So I don't know. It sucks I can't just have O'Reilly's order all these and then I can go down there, see what fits, and then bring it all back. Instead, now I have to pay for it, bring it home, and then whatever I don't use I gotta pay return shipping on, which really sucks a lot. So I don't know. The cheapest option is to buy the GM impact, this guy here, and see if it fits differently. And if it works, go until I slip the clutch or break the input shaft, and then buy a Dodge one and see what I can come up with there. I think this clutch, I don't know, it's pretty cheap. Come on. 97. Oh, look at that. It's already open. The impact was $89 for the GM. And I think the Dodge was $89 as well. I don't know. You can scroll back through the video easier and I can pull it up on here. So, oh, that's blurry, isn't it? Yeah, let's rearrange it a little bit. There you go. So, yeah. This one here, the Impact Organic, is $90. Or you go the heavy duty one. I think they're similar design. Yeah, looks just like the other one. Just, I don't know what the difference is. So, I guess the difference is $40. Yeah, for something that might not work. Kind of tough. Today's the 1st of November. I got 8 more days before I should buy anything, but it'd be pretty cool to buy something now so it's on its way, and then I could play with it. Otherwise, everything just kind of has to sit for a week until I can afford to spend more money. But yeah, really interesting. Here's the 6.5 friction disc. from this point forward, just assume I'm going to say the wrong word and know what I mean, and assume that I know what I'm talking about whenever I talk about it. But anyhow, this is the 6.5 pressure plate, and the Duramax pressure plate is up here on the bench. Bring it down. Hard to believe that, well, I suppose you get a little more clamping force if you make that thicker, but didn't see that one coming. That was completely threw me for a loop. Yeah, look at this is off my S10 and 4.3 in it. That thing's got a lot of torque. Just ripped the center out of it. But it's got, you know, it's like a hot dog in a hallway here. So, I know I can make something work. I just don't know what I have to do yet. Also, while we're comparing pressure plates, where is that little thing at? Right here. Mind the mess. I just built a house. Oh. Look at how much surface area that one has compared to the other two. That's pretty wild to me. I figured, you know, you'd want more surface area with more torque, but I don't know. It's kind of interesting. Anyhow, I think I'm going to stop the videos here for now. I don't know if I'll throw the stuff up for the electrical yet. Maybe I will, just to show how to build a bench harness, but for the mechanical side, we're kind of at a standstill. So, yeah. Such is life. Alright, well, I'll probably talk to you guys in a week. Well, we are back. It's Friday, and we got some updates. Behind everything is our third friction disc. So we got 3 of them now. We got Duramax 6.5 and a brand spanking new 6.5 sitting right down inside of our Duramax pressure plate. It's a little greasy. Probably ought to clean it so I don't start myself off on the wrong foot. This is kind of neat. Let me flip this thing over and take you in for a closer look. Right now we've got the flywheel side up, the flywheel side up, and this one, well, you're on the corded phone tonight. She's almost dead. This side here does not have any markings on it for flywheel side or pressure plate side. And some things that I noticed is on this flywheel side, all the laminations are to the pressure plate, and there's no ring here. On this one here, the ring sits high. This is flywheel side, and here all the laminations are to the pressure plate. This one, we've got a flush ring, and here's all our laminations. So I'm gonna, yeah, I think this here is gonna be the flywheel side. And also looking at the pads on here, they're kind of shaped not square. And if you look at this one, same thing, the angle, the long edge is, you know, pointing outwards. If you flip this over, oh, it points the same way, don't it? Never mind, that was a stupid comment, but it certainly seems like this is pressure plate side. So, we take this guy and plop him right on in the pressure plate, and he's got all this room to move in here, which is pretty sweet. This here, this is the impact from Rock Auto, and right here is our packing slip. So this is the part number for that friction disc. I think it's gonna work. The jury's not out yet because this still has this nose that sticks out. That's very similarly built to this one, but you know, looking at them, it looks smaller. You know, this is a lot more laminations here compared to this, and then this sticks out about the same as this, so you know, it might work. Only way to find out is to go ahead and bolt her up. Oh, I am stupid, I put that the wrong way. That's me showing you that it fits with a bunch of room. This is flywheel side. Let's not be stupid. Right? Smooth side of the flywheel. I also checked it does fit inside the flywheel both ways. Alright, we're gonna grab the cord and take it with us. So, take this guy and stick him in here. It fits that way and doesn't hit anything. It also fits that way and doesn't hit anything. So if we absolutely have to, I know it's probably against the rules, but I'll run it backwards. I'm guessing it's symmetrical inside, but it's probably not, and then I'll probably regret it, and then I'll probably break it, and I'll probably do it again. But, you know, that's the current state of affairs. Much better than last week. I'm glad I rolled the dice on it, so yeah, next time you see a video, it'll be with all that stuff bolted onto the flywheel. Maybe I'll clean all the grease off the flywheel too. And then yeah, we'll see if our slave clears with the bell housing on it. That's the next step. I guess next time you see a video, the second half of this video, you'll see if attempt number 2 works. So stay tuned. So I know I said the next part was going to be put the slave in here and test fit and everything. Well, I got excited and did it anyhow without videoing it, and we're here. Namely, because it didn't work. So instead of trying to measure with the video and everything, I made a drawing. So the 98 internal slave here and my slave are identical. They're both 3-inch in full compression. I squeezed them on the vise and measured from the face of the bearing to this face, which will be the back of the bell housing, right? Those two are going to be flush up against the transmission. So then I measured from the pressure plate fingers to the face of the bell housing that's up against the transmission, and I got 2 7/8. That's a 7. So we got an 1/8 inch interference. Mildly unfortunate. Gonna do a Rev 2.